Section 4.1 has the wonderful title Divisibility. We are going to look at relationships between numbers in this section and taking numbers and breaking them down into simpler pieces. That's the idea. So the first thing that we're going to look at is what the definition is of the word divides, and a little bit of notation that you might not have ever seen before for this notation too, or for this definition too. If A and B are whole numbers, we say that D divides A. It's written D and then a vertical bar and then an A. If and only if there is a unique whole number Q such that A equals DQ. If D divides A, then D is a factor or a divisor of A, and A is called a multiple of D. So I know there's several things for you to fill in that definition in your notes, so fill those in first, and I'll give you some numbers to explain that you know all this already once I put numbers in there. Part of this definition that might really truly be like, I've never seen this before, is the notation right here. Okay? It kind of feels like you're almost looking at a fraction, except that it's in reverse order. Okay? The first thing is what's dividing what's second. D divides A. So let me give you an example. We're going to use the example 4 divides 20. Okay, this is written 4 divides 20. And this is true because 4 times 5 equals 20, and 5 is a whole number, right? This number 5 right here is the Q that's referenced above, right? The reason that D divides A is because D times Q equals A. The reason that 4 divides 20 is because 4 times 5 equals 20. These names down here, sometimes people get them interchanged, so be careful. D is divisor, it means it divides it. M is multiple, it means it's in the multiplication table of it. Right? It's in the multiplication table. So the 20 we would say is a multiple of 4. And 4 is a divisor or factor of 20. Okay. For any whole numbers A and D, if D divides A and N is any whole number, then D divides N times A. So we're going to go ahead with the example I just gave you, 20, right? 4 divides 20. Then that means that 4 is also going to divide 20 times anything else. 20 times 2, 40. 20 times 3, 60. 20 times whatever will also be a multiple of 4. It will be able to be divided by 4. And if you want to think about that in terms of fractions, which I know technically we haven't done in this class, but you guys have done fractions before, you know that if 20 is divisible by 4, I could write it 20 over 4, and this would be a whole number, correct? But what would happen if I multiplied that 20 by something else on top? Say I multiplied it by 5. Well, the fact that this still divides out means that the 5 doesn't make any difference at all in terms of the division, right? If it divides one part of the numerator's product, it's going to divide the numerator. So that's what's going on there behind the scenes a little bit. All right, theorem 4.2, which is what's next, has several parts to it, like a whole bunch, okay? We've got 5 bullet points to fill in, so you got lots of writing you get to do. And me too, apparently. I guess I didn't get this one in my notes, so we get to write them together. All right, so here's the first one. If D divides A and D divides B, then D divides A plus B. Let's just give a quick example in your mind to think of. Think about things that are even versus odd, okay? So if I have 10, I'm sorry, let's use 2. 2 divides 10 and 2 divides 12. What's 10 plus 12? 22, another even number, right? So will it be divisible by 2? Yeah. And there's nothing special about the evenness of it. That's just the example I thought of, okay? Now, what happens then if it divides one piece and not the other? So again, D divides A, but what happens next is we have D does not divide B. So you see this line, vertical line, and then you see a slash through it, kind of like a not equal sign. So this is a does not divide sign. So if it divides one piece and not the other, then what do you think happens when you try and add them together? Yeah, they will not divide the sum. Will not divide the sum. Now, I'm about to go on to the third one, but let me show you what the third one's not. The third one does not say if D does not divide A, D does not divide B, what happens? Because the answer is you don't know. It might divide if you add them together, and it might not. Okay? So we don't have a theorem piece about what happens when it doesn't divide each of the individual pieces.
On the second one, what would an example of that be?
Something like, so 2 divides 10, and 2 does not divide 5. Then 2 will not divide 15.
Oh, okay.
Yeah. Okay, we're going to do a little bit with subtraction now. If D divides A and D divides B, and we have this extra condition that says A is greater than or equal to B. I'll talk about that in a second here. But then, what do you think is going to happen when we subtract two numbers that were each individually divisible by D? It is going to be divisible, yes. I mean, we can use the same numbers I did before. You know, 2 divides 10, 2 divides 12. If we subtract them, 12 minus 10 is 2, 2 divides 2, okay? The condition right here, why do you think this condition is right here? Yeah, and we're really only working with positive numbers still. We won't work with negative numbers till we get to chapter 5. So they're trying to keep things in the whole number system. So they're saying you still need a positive number to talk about this way. Okay? All right, excellent. If D divides A and D does not divide B, but you still have that A is greater than or equal to B, what do you suppose then? Will it divide or will it not divide?
No.
Yeah, it's not going to divide, just like on part B, if you will, of this definition or this theorem. It didn't divide. Right? So you can actually use the example that I kind of have written over there on the side when Hannah asked above, what happens over here? Well, 2 divides 10, 2 does not divide 5. It's 10 minus 5. 5. 2 does not divide 5. Okay, you do the subtraction, it's not going to work. All right, the last one here does it in reverse. If D does not divide A, but D does divide B, again, A is greater than or equal to B. So it's almost like the line before. It's just the difference in the ordering. What do you suppose happens when you subtract? Divides or not divides? Yeah, it does not. For the exact same reason as before. We just have it in reverse order. So if you've imagined that we had 2 does not divide 9, 2 does divide 4, right? What's 9 minus 4? 5. 2 is not going to divide that 5 either. Why do you suppose we have this third condition here? You know, it's kind of like these two go together and these three go together. We have this third one here. Why did we not need a third one up on top? Why did I not need to worry about reversing? Because the first one is addition, and addition is commutative. That's why. Subtraction doesn't have a commutative property. That's why it's written as a separate bullet point. Yes, ma'am?
So these matter because of, addition and subtraction, but, if you have multiplication, kind of like when we did the 20 times 5 over 4, it wouldn't matter.
Right. These do not say anything about multiplication, only about addition and subtraction. Yes. All right. What we're going to move into next is we're going to move into the divisibility tests for specific numbers. You know these. You may not have thought about them in these specific ways before, and maybe you don't know all of them, but you certainly know some of them, okay? So the first divisibility test we're going to look at is the divisibility test for 2. The divisibility test for 2 says a whole number is divisible by 2 if and only if its units digit is even. Not talking very well. Units digit, the ones place, right? When you decide if a number is even or not, do you look at the whole number? Like every single digit in it? No. None of the other digits matter except for the ones digit, right? That's what the units digit is talking about in this one. So the divisibility test for 2 means you only look at the units digit, okay, that last place value, and it has to be 0, 2, 4, 6, or 8. The same is true for divisibility by 5. You only look at the ones digit. If it's a 5 or a 0, it divides by 5. And then for the tens divisibility, if the units digit is a 0, it divides by 10. So these three are grouped together because they all have the same process by which you make the decision. You look at the units digit and you make the decision. Is it a 0, 2, 4, 6, or 8? Then it's even. Is it a 0, 5? Then it's divisible by 5. Is it a 0? Then it's divisible by 10. And in fact, if it's a 0, it's divisible by all three of those, right? Yeah, because 0 is in all of those lists. These are the ones that you have been most likely exposed to the most. Look familiar? Yeah, they should. Okay. The next two are grouped together. They probably are less likely that you've seen them before. Divisibility tests for 4 and for 8. Okay, so for 4, a whole number is divisible by 4 if and only if the last 2 digits as a 2-digit number is divisible by 4. Okay, so if the last 2 digits end in 1-6, is it going to be divisible by 4? Yes. If it ends in 1-8, is it going to be divisible by 4? No. And if it's small enough, you can look at that and just know, because you know your multiplication tables of 4s, probably at least up to 40, right? If it's bigger than that, you might actually have to actually do a division step to figure it out, right? If they give you the number 62, you may or may not remember. You may or may not know. You might actually have to try to do that division. But think with me. Calculator aside, if you were trying to decide if a number was divisible by 4, would it not be easier to test the division of the last 2 digits than the whole 6-digit number? Yeah. Well, of course it would. Okay? The other thing that you should be aware of is if the number is odd, could it ever be divisible by 4? No, not possible. You can think of that in a couple of ways. You can either think about your multiplication table of 4s, multiples of 4s, 4, 8, 12, 16, and think about it sort of deductively, right? You think through, like, I don't see any odds, they must all be even kind of thing. Or you can think through it very inductively, like why this is going to happen. What's the rule? What's the deal behind there? Well, if a number is divisible by 4, it's also divisible by 2, isn't it? And all the numbers that are divisible by 2 are even. So there we go. Anna.
So like when you say like if and only the last 2 digits value as a 2-digit number, you mean like you could have a number like 432, but it's the 32 is divisible by 4.
Correct.
It doesn't have to be a 2-digit number.
Correct. It's the last 2 digits of the number. Exactly. Okay, so what I don't want you to think is that each of the individual digits themselves must be. That's
like
actually not a true statement.
422, 424.
Right.
That'll still work.
Yeah, but like if you did the number 24, 24 is divisible by 4, but like the 2 in 24 is not, right? It's the 24 as a whole value that we want. Okay, the next one is less helpful than the one for 4. So it's a divisibility test for 8. So if you've got the divisibility test for 2 and you look at the last digit, and you got the divisibility test for 4 and you look at the last 2 digits, then the divisibility test for 8 is you look at the last 3 digits. That's not probably something you got stored in your memory, unless it happens to start with a 0, like 016. And you're like, yeah, 016 is divisible by 8. I know that one, right? You might not know this one. But again, is it easier to divide the 3-digit number by 8 than the actual full-out 6-digit number by 8? Yeah, it is. Okay, it's still easier to do that process. So it's still a valuable test, just not as easy to use. Okay, so if the last 3 digits as a 3-digit number are divisible by 8, then the entire 6-digit, 8-digit, 12-digit number, whatever it is divisible by 8.
So what were you saying if it is like 016?
If it were 016, you would know that 016 is the same as the number 16, and 16 is divisible by 8. So you would know that one off the top of your head. But like as soon as the number is like in the hundreds, you probably don't know it off the top of your head. You probably have to actually figure it out. So, okay, we have 2 more that are grouped together, 3 and 9. Has anybody seen the divisibility test for 3 before?
Yeah.
Do you remember what it is, Amy?
If you add all the numbers and they equal something that is divisible by 3, it's always going to be divisible by 3.
Have you guys seen that one before?
Yeah.
It's okay if you haven't. It's a really helpful one. So yeah, that's a very useful tool. And the cool thing is that it's actually the exact same thing for 9. You add all the digits and if it's divisible by 9. So let me let you write this down. Yes, Leah?
Have you ever seen the multiplication piece for 9 like with your hand?
Yes. Yes, I have.
I learned that in like 3rd grade.
Yeah, it's super cool.
I was like, what?
I'll let you show everybody here in a second after we get through these. But yeah, it is really cool. Divisibility test for 3. What you do is you add all of the single digits together. So the number's 432. You add 4 plus 3 plus 2. Okay? Whatever the sum is that you get, if that sum is divisible by 3, the original number was divisible by 3. If the sum is divisible by 9, the original number is divisible by 9. Super cool test. Super cool test.
So, like, how would you ask a question like this? Like, when you just ask, like,
Yeah, you have
348 divisible by 3.
Yeah, you can ask it very directly like that. That's how you're going to see one that I'm going to give you here in a minute. You can also, for those of you who are sort of thinking toward the fact that you're going to do a presentation and maybe you're doing a presentation on this material at some point, you can talk about the fact that there's 432 people in the room and you want to know if you split them into 3 groups, are you going to have an even split, right? Are the groups going to have the same number of people? You can do something like that too from a very practical standpoint. So it is actually not just like for the fun of it. I mean, for the fun of it's good enough for me, but probably not for everybody. Okay, we have 2 more tests. Our next test, and they're standalone tests. There's nothing related between the 2 tests, okay? The first test sounds really funky and weird, so just write it down. I promise when I show you how to use it, you're going to be like, oh, that wasn't that hard, but it's really like the most awkward thing ever to write down, okay? Divisibility test for 11. A whole number is divisible by 11 if and only if the sum of the digits in the places of even powers of 10 minus the sum of the digits in places of odd powers of 10 is divisible by 11. Such a fun thing to write down. That's the most writing you have to do today is this one. Okay, let me show you how to use the divisibility test for 11, because it's not hard to use. It's just so weird to write down. I'm going to write down, and I'm making this up on the spot. This is how useful this product and this process is, truly. You've got a really long number. It makes more sense for longer numbers, but you can use it with any kind of number you want. So this is a 2, 3, 2, 1, 9, 2, 8, 6. You want to know, does it divide evenly by 11 for whatever reason? You've got 11 sets of papers and you want to split them up in 11 groups and whatever, okay? All right, so you're going to circle every other number. And it doesn't matter whether you start on the left or the right. It doesn't make any difference. You're going to add up all the numbers you circled. So 2 plus 2 plus 9 plus 8. What do I get? 21. That's what I got to. 21. All the other numbers, you're going to add them up. Okay, so 3, 1, 2, and 6. I think that's 12. Okay? So it's every other place value you're adding up, you're grouping together. And what you're going to do is you're going to subtract these two. I don't care which order you subtract them in, just bigger minus smaller is all our concern is. So what happens when I take this 21 minus the 12? You get 9 on this one, right? Okay. If 9 is divisible by 11, the original number was as well. If it's not, then the original number's not. So does 9 divide by 11? No. So this original number that I created does not divide by 11 either. It's not a hard test to use. It's just this awkwardest thing ever to write down. Yes, ma'am?
If it's smaller than 11, it can't be like...
That's a great question. There is one number smaller than 11 that would work. Any idea what it would be? 0. If you actually had gotten, say for instance, 21 and 21 when you subtracted this, or when you added these together and so subtract to 0, 0 is divisible by everything. So if this were 0 when you did that, then it would still work. But anything smaller than that otherwise, Emily, wouldn't. So you're looking for either 0 or 11 or 22 or 33. You're looking for those numbers when you subtract. If you get them, it's divisible by 11. If you don't, it's not. All right, divisibility test for 6 sounds very intuitively obvious. I'm not going to go into great length of detail why this is true right now because we're going to do an exercise when we get to the very end of this lesson as to the why this is true. So this one says, a whole number is divisible by 6 if and only if it is divisible by 2 and 3. And the reality is that 2 times 3 is 6, and that is what's going on there, but there's really far more to it than that I want to sort of let you ponder later. I want to keep moving at the moment. We'll come back to this when we get to the end of this lesson, okay? Okay, everybody good with that? We're going to do an example. We have the number 24,015. And we are going to go through all of those divisibility tests one at a time from smallest to largest and check, is it divisible or is it not by those numbers, okay? And your book does not require on the problems like this for you to justify your answer. I would make sure that at least in your mind you know the justification for the answer because I'll guarantee if I ask you the question on the test, I'm going to ask you why, right? I don't want to guess. I want you to know that you really know why and that you know the right reason why. I had a student not too long ago in her presentation who totally butchered one of the rules. And she was right, it was divisible by whatever the number was, I think it was 3, but not for the reason that she said. She was completely wrong in her reasoning. Well, that's as bad as being wrong because she really was wrong, even though she said the right answer. So we're going to go through these numbers one at a time. We will justify them sort of verbally aloud. I won't write down the why for this, but we'll make sure that we know the why out loud. 2, is this number divisible by 2? No, why not? Yeah, the one's value is a 5 and it's odd. All right, how about 3? Is this number divisible by 3? Yes, how do you decide? Yes, 2 plus 4 plus 0 plus 1 plus 5 is what? 12? 12 divided by 3? Yes, therefore 3 will divide 24,015. How about the number 4? No, why not? Yeah, so this one was 5's not even. This one is 15. Actually, let me say it this way. 4, just so we have practice writing it, does not divide 15. All right, that's our notation that we learned just a little while ago. It does not divide. How about 5? Yes, why? It ends in 5. I totally told you I wasn't going to write these down, but I got to write something justification because that's just the way it is. How about 6?
No.
No, what's wrong?
Because it's not divisible by 2, it's only divisible by 3.
Right, it's not divisible by 2, and it needs both of them.
Wait.
Divisibility test for 6 means it has to divide by 2 and 3. 3 works, 2 doesn't. Yeah. Okay, 6, what's next? 8. No, and this is actually a pretty good example of what I was telling you before. This ends in 015, right? It's really like a 2-digit number, even though that's the 3-digit number because of the 0. And we know that 8 does not divide 015 because 8 doesn't divide 15. You almost get 4 and 8 for free anyway, though, because it's not going to work because it's not even, right? I mean, if 2 didn't work, 4 and 8 have no chance. Let's see, 9 is next. No, why not? Yeah, the sum was 12 of the digits, and 9 does not divide 12. 10? No.
It ends in a 5.
So it doesn't end in 10. It doesn't end in 0, I should say, I'm sorry. And the last one is 11. 11 requires a little bit of work, right? We have 2, 4, 0, 1, 5. So let's circle every other digit. 2, 0, 5. What does that add up to? 7. And 4 and 1 adds up to 5. 7 minus 5 is 2. And 11 does not divide 2. So this one is a no. That's how quick you can go through those. You're testing all of the going through all of the tests for them. All right, we are going to classify the next set as true or false. Again, it doesn't actually say we have to justify, but we should probably have a good idea of why it's true or why it's false when we write down true or false, because if I ask you on a test, I'm probably going to have you do something, right? Yeah. You guys know me enough to know that by now, yeah? Oh, yeah. All right. It says, if a number is divisible by 6, then it is divisible by 2 and 3. That is true, and not only is that true just sort of as it looks, but it's really the very definition over here. Do you see this phrase that says if and only if? Have you seen that ever before? It means the statement can be read from front to back and from back to front. It means I can say a whole number is divisible by 6 if it is divisible by 2 and 3. And I can say if a number is divisible by 2 and 3, then it's divisible by 6. Are you with me? I can put the if in either place. If it's divisible by 6, it does this. If it's divisible by 2 and 3, it does this. Okay? So this is actually one direction of that if and only if statement. It's straight from the theorem or the definition. How about the second one? If a number is divisible by 2 and 3, then it's divisible by 6. True. That's the other half of it, right? That is the other half. So both of these are straight from the definition, or the theorem, I think it was, actually. So by theorem, or by definition, by the number test. Okay, C and D require a little bit more work, okay, because we don't actually have this test written like this for the test for 8. It says, if a number is divisible by 8, then it's divisible by 2 and 4. That is a true statement. And the reason that's a true statement is because 8 is itself divisible by 2 and divisible by 4. Okay, so that works. D is a little different. D says if a number is divisible by 2 and 4, then it's divisible by 8. That is actually a false statement. And you know, when a statement's false, what's the easiest way to justify why it's false? A counterexample. So can you give me a counterexample?
12.
Yeah, 12 is a great counterexample. 12. Is 12 divisible by 2 and 4? Yes. Is 12 divisible by 8? No, it isn't. So this one doesn't work the other way around, which is kind of weird because it worked for 2 and 3 and 6. We'll talk more about that one later. All right, a couple other things we're going to look at. Example 3. Answer each of the following without actually performing the division. Explain how you did it in each case. And if a number is divisible by, why does that say that there? I think that's a copy-paste issue. Who knows? And what's crazy is that means it's been on there like for a whole year when I created these slides originally. That shouldn't be there. Okay.
It's not on ours.
I know. It's because yours is in a different document. Yeah, these are a PowerPoint document, and you guys have a Word document for your notes. That's why it's not there. Fun times. I guess I need to get that fixed. All right. Let's look at the numbers. The first number is 34,051. We're not going to really actually divide this because the directions said I don't really need to. How could I make the decision if this actually is divisible by 17 without actually using a calculator dividing?
Break it up into is 34 divisible by 17 and 51 divisible by 17.
We had some like breaking up property like that of mental mathematics in the last chapter, didn't we? Isn't that interesting that we're using it now, right? Who knew? All right. Yeah, I agree. That's definitely a good way to think about it. So if you break this up into pieces and look at it in pieces, the numbers were construed on purpose to do this, right? Now, you probably don't know a multiplication table of 17s, but maybe you could construct a few of them a little bit quickly. Leah, what did you say? 17 times 2 is 34. So we sort of get this one very nicely. So 17 will divide 34. That's nice. It's times 2. What about the 51? Yeah, 17 also divides 51. It's 17 times 3. Okay? Even if you weren't sure about the 17 times it, if you did 7 times 3, at least you get a 1 in the ones digit. It's a good enough reason to try. You can keep going on, right? Yeah. So this one is it actually works, yes. And it works because it divides those two pieces when broken apart. Using that same logic, what can you tell me about part B? 19 divides 19, that's good enough. But then what?
30 or 19 is not divisible.
I think you said it backwards, Amy, but yes, the 19 does not divide 31, right? It doesn't. 19 does not divide 31. So this one's a no for the exact same reason. Now C and D are a little different. They don't even give you the whole number, and it would not be in your best interest to multiply this out. It would be in your best interest to look at what's in there. Will 5 divide 2 times 3 times 5 times 7?
Yes, because there's a 5.
Right. If I were to multiply this out, because there's a 5 in it, it's going to end in a 5 or a 0, right? So it's going to be divisible by 5. 5 is one of the factors. And that's actually what divisibility means. I could also ask, is 2 times 3 times 5 times 7, does it divide by 5? And the answer is, yeah, because there's a 5 in that product as it's listed out. So this one's a yes, because 5 is a factor. Okay, then, what happens if I add 1 to it? Yeah, that 5 or that 0 that it ended in is not going to be a 5 or a 0 anymore when I put plus 1 on there. What's it going to be? It's going to be a 1 or a 6. Yeah? Yeah, so this one's going to be a no. And it's because it will end in a 1 or a 6 because I'm adding 1 to something that ended as a 0 or a 5 on the previous part. All right, I know we're just like running out of time. I think we can do one more example and we'll finish it up next time. And we'll talk more about that divisibility rule by 6 that I keep evading with you. If 24 divides the number m, what other numbers would you think divide m? Okay, so 2 and 3. Why? Okay. Let's do it in a little bit different fashion. I agree, 2 and 3 work. But let's do it a little bit differently. Let's do 2 and 12. Why would I put 2 and 12 together? Not quite.
If you multiply
2 times 12 is 24.
If you multiply them, you get 24. Multiples, or factors, excuse me, occur in pairs. So if I were to multiply 2 times 12, I get 24. So I know 2 and 12 are going to both work because both of them divide 24, because they multiply to give me 24. So what would I use with 3 that you had mentioned before, Amy? 8. 3 and 8. Those will both work because they give me 24. Anything besides the 2 and the 3?
6 and 4.
4 and 6. And do you notice as I increase the column on the left, I am decreasing the column right after it in the middle? And the cool thing about doing it in that fashion is that at some point I realized there are no numbers left in between that work. The only numbers between 4 and 6 now are 5, and 5 times 5 is not 24. There's one more number that we're missing here. 1 times 24. Yeah, and, you know, sort of it should be at the beginning, kind of, if you think about the pattern and the way we wrote this. So this is sort of what we should be thinking as we're thinking about these numbers. The answer then, of course, is all of these values over here, except for 24 because we already knew the 24. So it would be 1, 2, 3, 4, 6, 8, and 12. These would be all the values that would be the answer to our question.